What if vegetation analysis could be fully automated using satellite data? In this video, I will show a workflow in Google Earth Engine that automatically selects the best Sentinel-2 stands, calculates NDVI and EVI, performs vegetation zoning, builds time series charts, and exports the results. And the entire analysis is performed automatically with a single script. Hello everyone! In this video, I am going to demonstrate how to automate vegetation analysis using Sentinel-2 satellite imagery in Google Earth Engine. This workflow can be useful for GIS specialists, remote sensing analysis, researchers, agronomists, environmental monitoring specialists, and anyone working with satellite data analysis. The main idea of this script is automation. The workflow automatically searches for the best satellite stands, filters cloudy pixels, calculates vegetation index, performs vegetation zoning, generates charts, and exports the results. This approach allows you to create a repeatable workflow for vegetation monitoring. Before starting the analysis, we first need to define a region of interest. In this example, we will draw the area directly on the map in Google Earth Engine. For demonstration purposes, let's take an example from the United States. We can choose Nebraska, which is a region with the large agriculture areas. Here we draw polygons representing agricultural fields that we want to analyze. These polygons represent the fields used for vegetation analysis. Next, we combine them into a single region of interest or ROI. This ROI will be used for selecting satellite imagery, calculating vegetation index, generating statistics and charts. I'm just going to draw a quick polygon here to represent a file. It's not very precise, but that's fine for the demonstration. And in this script. How that the polygons are ready, we can simply run the script. And this is where this automated workflow begins. Once the script runs, it automatically processes the analysis for all selected dates and for all filled polygons. If we open the console, we can see the list of target dates defined in the script. Below that, the script prints the actual Sentinel-2 stands that were selected automatically. These images were chosen based on several parameters, including cloud percentage, coverage of the region of interest, and the number of clear pixels. Showing the result first. RGB and layer outputs. The first thing we get is a set of map layers. Here I am opening the generated layers one by one. For each selected date, the script creates an RGB satellite image, an NDVI zoned layer, and an EVI zoned layer. This allows us to visually compare vegetation conditions across the season. Next, the script generates charts. Each chart is built separately for each field polygon. So in this case, one chart is created for field 1 and another chart is created for field 2. These charts show the mean NDVI and EVI values over time, which helps us understand how vegetation changes during the season for each field individually. After that, the script also generates export links. These links allow us to download RGB outputs, NDVI maps, EVI maps as PNG files. So before even looking deeply into the code, we already have a complete automated output, map layers, charts, and export-ready results. We've seen the outputs. Let's go through the code and see how the workflow is built. In this example, the study period covers the growing season from May to September 2025. It defines 5 target dates, representing different moments during the season. For each of these dates, the workflow searches for the best available Sentinel-2 image. Next, the polygons we drew on the map are turned into a feature collection. Then they are combined into a single array, which is used for image filtering, clipping, and statistical calculation. So the manually drawn polygons become the special basis for the full analysis. After that, the script connects to the Sentinel-2 surface reflections collection. This dataset is well suited for vegetation analysis because it provides multispectral imagery with 10-meter spatial resolution. The script automatically searches for the best Sentinel-2 image for each target date. It looks within a time window around the date, filters scans by cloud percentage, and evaluates how well each image covers the region of interest. Based on this criteria, the best scan is selected for the analysis. After selecting the image, the script applies cloud masking using the Sentinel-2 Sense classification layer. This removes clouds, shadows, cirrus, and snow pixels, ensuring that the indices are calculated only from clear observations. Calculates NDVI and EVI, each with its own classification range, and automatically generates legend panels for both indices. The values are then grouped into vegetation zones, and the script creates RGB, NDVI, and EVI layers for each date. It also calculates mean index value for each field, generates charts, and provides PNG export links for the results. So, this example shows a complete vegetation monitoring workflow in Google Earth Engine. We draw field polygons, run the script once, and it automatically generates map layers, vegetation zoning charts for each field, and export links. This type of workflow can be useful for agriculture monitoring, environment analysis, and seasonal vegetation studies. If you find this workflow useful, don't forget to subscribe. I'll leave the full code and resource in the pinned comment below. Thank you.